behavior of subatomic particles as small as electrons could be predicted. Well, Bardeen went over the figures. He couldn't find anything wrong. So why didn't the field effect device work? That's what Shockley wanted to find out. So he assigned Bardeen and his new close personal friend Walter Brattain to come up with the answer. Shockley then envisioned himself returning to the laboratory to complete the invention of the transistor.
I think he was simply giving them a problem that needed to be solved. Once it was solved, then Shockley could go back to the business at hand, which was to actually make a solid-state amplifier.
Generally, Shockley had backed off from it and had enough brains to leave them alone. Whether he did it deliberately or whether this was just a function of his personality, I'm not sure. But essentially, the two of them worked alone.
Bardeen thought he understood why Shockley's device didn't work.
Simply put, he said that there were things happening on the surface of the semiconductor that was preventing this field from penetrating into the body of the material.
Bardeen believed that electrons were trapped on the surface of the silicon, creating a shield so the electric field could not reach the electrons on the inside. The pair set out to understand the mysterious details of this surface barrier. Walter Brattain spent most of his time in the lab, building and conducting experiments. John Bardeen would suggest new experiments and interpret the results.
It's John who does the heavy-duty thinking, and Walter, who was a very good experimentalist, with John around, was a great experimentalist. And Walter knew that.
Brattain and Bardeen worked very closely, but would often call in Shockley and other members of the team for advice.
They were embedded in the remarkably productive environment of Bell Labs at Murray Hill in those days. They had access to other people within Shockley's group. They had access to other people outside in metallurgy and chemistry. And they were perfectly free, without any bureaucracy, to call on help wherever they needed it.
Walter Brattin's diary reflects how pleased he was with the team.
I cannot overemphasize the rapport of this group. We would meet together to discuss important steps almost on the spur of the moment of an afternoon. We would discuss things freely.
Brattain and Bardeen began tinkering with thin slices of silicon, searching for a deeper understanding of the surface barrier.
And they started making electrical measurements on the surface of germanium and silicon and varying the surface properties to see if they could confirm his theory.
They dipped the silicon into liquid nitrogen, figuring this frigid bath might somehow neutralize the shield and allow the electric field to penetrate deeper where it could stimulate the flow of electrons. It worked, but only very slightly. Enough, however, to convince Bardeen his theory was correct. Unfortunately, this early victory was just a tease. Brattain and Bardeen could make no more headway into unlocking the secret of the surface barrier. Winter turned to spring, and spring to summer, summer to fall, and still no progress. With nothing to show for their efforts, tensions mounted, especially between the vocal Brattain and his ambitious boss. Phil Foy remembers one incident in particular.
Shockley was at the blackboard in a seminar explaining some complex physical principles. As he got into the explanation, Brattain began to click 2 quarters in his pocket. Shockley turned to Brattain and said, "Will you please stop clicking those quarters? Walter, I can't think." Walter commented, "Well, I can't think unless I'm doing it." Shockley next reached into his pocket and gave him $2 bills. Said, "Here, Walter, rub these together."
Finally, in the fall of 1947, a sign of progress. Brattain had been struggling with an annoying problem of water condensing on the silicon surface. He could have gone through the time-consuming trouble of drying everything out. Instead, he played a hunch.
He thought, well, maybe rather than doing that, I can just dump the whole system in the water or other electrolytes. And so he tried that experiment, and he discovered that under those circumstances, they actually got an effect.
The experiment worked, much to the surprise of everyone. even when he placed just a drop of water on top of the semiconductor. Apparently, charged particles in the water were migrating down to the silicon and neutralizing the surface barrier. Bratton realized they were onto something big.
I'd taken part in the most important experiment I'd ever do in my life.
Thus began what Bell Labs would eventually call its Miracle Month. Bratton and Bardeen were hot on the trail. It seemed like almost every day they were making discoveries that brought them closer to overcoming the surface barrier. The device worked even better when they switched from silicon to germanium. But there was still one problem, one that would be especially troublesome for a phone company. It was sluggish, not responsive enough to amplify the complex tones of the human voice. Perhaps the liquid was slowing down the response. Why not just get rid of it? The history of invention is certainly full of serendipitous events, happy accidents. And a key discovery made at Bell Labs in December of 1947 is certainly one of them. Because in his efforts to do away with the liquid, Walter Bratton, almost by accident, stumbled upon the transistor. Bratton had an idea for a new device. Instead of the metal plate, he would substitute a spot of gold and keep it separated from the germanium by a thin oxide film, sort of a rust that sometimes forms on germanium. He hooked it up, and nothing happened. No amplification at all. It was as if they had gone back to square one. But they didn't give up.
John Bardeen is one of the great scientists of our century. He had unique characteristics of seizing on a problem and never letting go until he understood it down to the depths and solved it.
They kept at it, trying many different combinations of setups and voltages. And shortly before Christmas of 1947, their perseverance paid off. Phil Foy was in the lab that day.
Bratton was on the opposite side of the room. He had a bench and he had his small microscope. He was actually looking at surface effects, and he noticed that he had current gain on that scope. And he let out a sentence. It wasn't a loud sentence. This thing's got gain.
It turns out that Bratton had accidentally washed away the thin oxide film, so the gold spot was in direct contact with the semiconductor. Instead of a field pulling electrons to the surface, as Shockley had envisioned, Bardeen realized they were injecting positive charges directly into the germanium.
Patience and fortitude, and things will come your way.
And so they actually built the first transistor on an entirely different principle than they had anticipated. It wasn't a field effect amplifier at all.
When Bratton actually saw the first transistor effect, it was his deep training to know he had something. He could have missed that, but that was the flash of genius. He knew he had something.
It was time to turn the experiment into an invention. On December 16, 1947, without discussing their plans with Shockley, the pair began to build a device. Immediately, Bratton encountered a major design problem. The wires touching the germanium had to be extremely close together, and they were very difficult to manipulate. Quickly, Bratton cobbled together an ingenious solution. He wrapped a strip of thin gold foil around a small plastic triangle. Slicing the foil in two at the tip, he created a razor-thin gap. He applied the power, and the device worked. Walter Bratton had just built the first transistor.
It was marvelous. It would sometimes stop working, but I could always wiggle it and make it work again.
And here you have it, the device that Bratton and Bardeen were so excited about. It's an exact replica, an actual working replica of their original transistor. Here is a slab of semiconductor material, germanium, the same kind of germanium they use in their transistor. It's sitting on a copper base. Power is applied to the bottom of the slab through this copper. A weak signal enters